section here. Let's see. Tyler, distance formula.
D equals square root
Big square root.
parenthesis x2 minus x1 parenthesis squared plus parenthesis y2 minus y1 squared.
Okay, there we go. And you'll remember we actually derived this in class using the Pythagorean theorem. We plotted a couple points on the xy plane, and then we made a right triangle out of it and figured out what the hypotenuse was using the Pythagorean theorem. So it says find the distance between the two of these, and people tend to make mistakes here, especially with the negatives. So you want to be very careful with this. So the distance between the two of these is going to be x2, so that's going to be -1. Write the minus and then go find the number that is x1. So that's going to be -4, quantity squared. And then this is going to be y2, so that's going to be 2. Again, write the minus from the formula, then go find the number that is y1, and that's -2. And then that's quantity squared. So this is going to be, well, this is -1 plus 4, so this is going to be 3 squared. This is going to be 2 minus -2, so this is going to be 4 squared. So this is going to end up being, let's see, a 9 plus a 16, so this is the square root of 25. So the answer on this one is 5. Okay, so it turns out to be a nice number. Did that on purpose. Okay, are there any questions there? Okay. All right. Well, when we derived the distance formula, that same idea can actually help us figure out what the equation of a circle is. So we want to remember what the definition of a circle is. Okay, a circle is a set of points that are equal distance, or we call that equidistant sometimes, from a given point. Okay, that equal distance is called the radius, and the given point is called the center. So the cool thing about this is you only need two things to define a circle. You need to know how big it is. In other words, you need to know what the radius is, and you need to know where it is. You need to know what the center is. So for example, if I just put a point right here, and I made a circle that's like that big, and then I made another one over here that's exactly the same size, these two circles can't be the same thing, even if this radius is exactly the same as that radius, because they're not in the same place. Okay, by the same token, if I use the same circle or the same center and a smaller radius, they're not the same circle. So keep that in mind. It makes circles a lot easier. You only need two things. You need to know where it is, you need to know the center, and you need to know how big it is. Pardon me. You need to know the radius. Okay? So here's what we're going to do. We're going to find the equation of a circle whose radius is r and whose center is h, k. And it says, find the distance between h, k and xy. So the center is going to be at a point, and we're going to call it h, k. So I'm going to put it right here. So that right there is h, k. And then I'm going to make a circle that looks like that. And I'm just going to draw in that the radius is r. So there's my circle that's centered at hk, and the radius is r. Okay, but I don't have an equation yet, because remember, equations relate x's and y's. So I'm going to put a point right here, and I'm going to call this x, y. Now, I could have put this point over here on the circle. I could have put it down here on the circle, down here on the circle. I could have put it anywhere on the circle. That xy pair is on the graph. It should make the equation true. We're just trying to figure out what the equation is. Now, there should be some equation or some formula that relates this point to this point and how far it is in between them. What's the formula that does that for us? The distance formula. So you could use the distance formula from scratch, and you could do, this is x2, y2, and this is x1, y1. Or you could go back and you could do the same thing that we did when we derived the distance formula, and you could make a little right triangle, and you could say, how far is it from here to here? How far is it from here to here? Doesn't make any difference. Use the distance formula or draw the triangle if you want. If we use the triangle, this x coordinate is x2 and this one is h. So this would be x minus h. That's how far it would be from there to there. What about this vertical distance right here? How about from here to here? It's going to be y minus k. So if I take the two of those and square it, that would be x minus h quantity squared plus y minus k quantity squared equals, what's that distance there? That's going to be r squared. And in fact, that's the formula right there. Okay, if you wanted to use the distance formula, the distance is equal to a big square root, x2 minus x1, quantity squared, y2 minus y1, quantity squared. x2 in this case is x, x1 is h. Whoops, that should be a plus. y2 is y, y1, that first y is k, quantity squared, and that would equal r. And then I can just square both sides and I get r squared equals x minus h, whoops, x minus h quantity squared plus y minus k quantity squared. Okay? So either way, they're both valuable techniques. I kind of like just drawing the triangle like we did when we derived the distance formula. Okay? So this is what we call the equation of a circle in standard form. Okay? When we say standard form for a circle, this means it's going to be very graph friendly. In fact, if you're given an equation that looks like this, you immediately know where the center is and you know what the radius is. So this right here, that number that's sitting right there, okay, or if we take the whole thing, the negative h, it would be the opposite of negative h. That's going to be the x coordinate of the center. And whatever is with the y, the opposite of that is going to be the y coordinate of the center. Okay? And that right there is the square of the radius. So again, it's a very graph-friendly form of the equation of the circle because it tells us the two things. It tells us what the center is. The center would be hk, and it tells us what the radius would be. It's going to be r. So if you're given the equation of a circle in standard form, it's kind of like somebody saying, hey, you know what? I'm going to give you a linear equation in slope-intercept form. That's a very graph-friendly form. Or saying, I'm going to give you the equation of a parabola in vertex form. Again, a very graph-friendly form. So this is a graph-friendly form for a circle. So in its simplest form, it looks like this. X squared plus y squared equals r squared. Now, the only way you could get x minus h quantity squared to be an x squared is if h is 0. And k would also have to be 0. So this is a circle that's centered at the origin because both h and k would be 0. So if we're given something like this, even though these look pretty ugly, they're actually really easy to do. Now remember, when you graph these, you want to make sure you make it clear you know exactly what you're doing. So you've got to label the important parts of a circle. You've got to label the center, where it is, and you've got to label the radius, how big it is. So let's go ahead and do this. What is the center? 0, 0. So I'm going to put the center on here, and what's the radius? Radius is 5. Now, here's how we're going to draw these. Everybody watch, please. Okay, in the long run, this is going to be much better. Now, if you don't use this all the time, that's fine, but at least keep this in mind. I'm going to go 5 units in every direction. So I'm going to go right and left 5 units. I'm going to go up and down 5 units. Now, sometimes it's tough to draw a nice looking circle. So one thing that you can do is you can kind of do a little dotted box around here. Now, you don't have to do this on every one of them, but by drawing that, it kind of gives you a little guide so you can make your circle look a little bit better. Okay, mine right now is looking more like a potato, but that's going to do. Actually, that's pretty good. It looks worse on my screen than it does there. So again, 0, 0, and then if you want to, you can draw in what a radius would be. The radius would be 5. So just make sure you label this stuff. This idea of drawing a little box around this so you can draw an accurate graph is going to be used again in 1050. So just keep that in mind. Okay, are there any questions? So how does this one compare? Same center, radius is just 3. So this is going to be a center of 0, 0. And we're going to go 3 units in every direction. So left, right, up, down. Okay, I'm not going to draw the box on this one. I think I can do this one all right. Okay, so there's the circle. And if it's pretty small, just say that the center is 0, 0. So indicate what it is, and then label that the radius in this particular case is 3. It's that simple. On easy ones. Any questions there? So let's flip the page over and let's take a look at the next type of problem. This one says, graph each circle, label the center and the radius. Is this in graph-friendly form?
Yes.
It is. So the question now is, without flipping the page back over, let's stop and see if we can figure out where the center is. Now, I need an x-coordinate and I need a y-coordinate. Okay? Clearly, the number with the x would be a good candidate for a choice for the x-coordinate of the center. But my question for you is it 4 or is it negative 4? The answer is 4. Can somebody remind us why it would be positive 4 instead of negative 4? They would cancel to be 0 and it would act like a 0. Okay, so the new center would be at 4 instead of 0. I like that. What about it slows the shape down by 4 units? It makes the shape 4 units later than it normally would. So instead of making it at 0, it's going to make it over here at positive 4. Okay, what about the y-coordinate? Answer there is going to be negative 2. Why does it move it down 2? Why does it go from 0, 0 down to here? Does the opposite of what you'd think because it's in parentheses. It makes the shape in the y direction 2 units sooner than it normally does. So it's going to make it at 4, negative 2. So we're going to put that right there. And what's the radius? Radius is 3. So again, let's go ahead and count. Let's go 3 units in each direction. And we're going to look about like that. Again, with a fairly small circle, as long as you've labeled this stuff, try and put it as close as you can, but that's what it would look like. We've got a center of 4, negative 2, and a radius of 3. Any questions? Okay, take a look at the next one. The next one's a little bit different. Go ahead and write down the center. Center would be negative 5, 1. So back 5 and up 1. So we're going to be about right there. And then what's the radius? Okay, the correct way to write this, because again, we'd want to do this in exact form where possible, is going to be 3 square root 2. If you take the square root of 18, pair of 3's, there's a 2 stuck on the inside, so it's 3 radical 2. So this is how you'd want to label that. Now, graphing 3 radical 2 is another story. 3 radical 2 is a little bit more than 4, okay? 18 is a little more than 16, so the square root of 18 ought to be a little bit more than the square root of 16. So we're going to go a little bit more than 4 in each direction. So we're going to go each direction a tad more than 4. This one might be a good idea to draw a little box around it. Okay. So it's going to look something like that. Again, there's the center, negative 5, 1. Back 5 and up 1 for the center. And the radius is 3 radical 2. Okay, are there any questions? Okay, take a look at example 4. Go ahead and read that to yourself. And did we already talk about this? And did that idea sink in? Because that idea is really important. The fact that if we're going to change the x before we square to help make the shape in the x direction, this is going to slow it down by 4 units. That's going to move it to the right 4. And if we add 2 to the y before we square to help make that round shape, that circular shape, it's going to make it 2 units sooner than it normally does in the y direction. That's why it's going to go to the right 4 and down 2. Okay? So it used to be at the origin, and now it's going to be centered right there. Okay, are there any questions there? So in other words, if you know what this one looks like, you should know what this one looks like just from those transformations. Okay? Again, that idea comes up over and over and over again. The transformations that we've been using to graph exponentials and logarithms, we use those all the time in 1050. Okay? And in college prep. Got it? Okay, let's take a look at the next ones. So we've got, I think, 5 more examples, 6 more examples. So take a look at example 5. Okay, this is a little bit different. It says, come up with the equation of a circle by the description. It tells you how big it is and it tells you where it is. You've got to come up with the equation. So in other words, it's given you h and k and it's given you r right here. If it's centered at the origin, what is it? X squared plus y squared equals square the 9, so that's going to be 81. So there's our answer there. If it's centered at 5, negative 6, we're going to do x minus 5, quantity squared, plus y minus k. In this case, it's negative 6, so this is going to be plus 6. Again, you can just do the opposite of whatever that number is. And then this looks really ugly. It's 11. Square the square root of 11, you get 11. So there's our answer right there. Okay, are there any questions? So we can go from a graph-friendly form of a circle to graph the circle, or we can go from the description of a circle and then come up with the graph-friendly form of a circle. Again, that's called standard form. Let's take a look at these next couple. This one says, find the radius, center in the radius, graph the circle, and label important parts. What's wrong with this? Everything is wrong with this. Parker is excused from class. Okay. Yeah.
Well, one that should be the radius, well, the square root of the radius is negative 15, but you have to move
Okay, so we got to move this to the other side. Right now it would look like the radius would be 0, so we're going to have to move that to the other side. There's a couple other things wrong with this, yeah. We have extra variables other than the x squared and the y squared. Now, this is going to work out just fine. This is a circle. We're going to be able to put it in a graph-friendly form of a circle, but what I want you to notice is this. Perfect square with x, perfect square with y. Perfect square with x, perfect square with y. Look at every single one of these that was written in standard form. Perfect square with x, perfect square with y. Perfect square with x, perfect square with y. Now, is this written with perfect squares of x and perfect squares of y? No, so guess what we have to do?
Put it that way.
Okay, what's it called when we make a perfect square? We're going to complete the square. That process does not go away. So we hopefully have got this memorized. I'll just remind you of how to do this on a couple of these, and then hopefully we'll be in good shape. So take a look at this problem right here. Here's what we're going to do. You mentioned a couple things. We've got this negative 15. That is not going to be part of our perfect square, so we're going to move it to the other side. Okay, we also have this extra x and this extra y floating around. They're going to be part of the perfect square, but we better gather that stuff together. So we're going to gather the x's together, gather the y's together, and then put any other constant terms on the other side. So I'm going to write x squared plus 6x. I'm going to save room to complete the square, plus y squared minus 4y, and then over on the other side is a 15. Everything that's written there in black was in the original equation, right? Okay. Now, I'm going to put parentheses around this and parentheses around this. If that happened to have a negative, which it won't in this particular section, you'd want to factor that out. Okay, and then we start completing the square. And the process for that is half the middle coefficient, 3. We're going to square that. That's a 9. Now, whenever you put a number here to complete the square, I taught you to do something else. What was it? Taught you to draw this line right here and figure out, what did I actually do to change this? I really did add 9. Now, on this one, I get to compensate on the opposite side. I get to adjust on the opposite side. So if I adjusted this side by adding 9, what do I do to adjust this side? Think about it for just a second. If I'm going to do both sides, if I can work on both sides, if I add 9 over here, I've got to add 9 over here. It's not the opposite. Okay? This isn't putting a parabola in vertex form where we can't screw up the f of x or the y, where we've got to do all our work on one side. We're working on both sides here. Okay? So the next one, half of this is -2. I'm going to square that. That's a 4. The number out front is just a positive. So I really did add 4. So how do I compensate on this other side? I'm going to add 4 there also. Okay, are there any questions? Okay, at this point, I can now write this in standard form. So this is going to be x plus 3 quantity squared. This is going to be y minus 2 quantity squared. And then over on this side, if I add those together, 28. That's really only about one line of work to complete the square on this one. Any questions? Okay, where's the center? -3 comma 2. And what's the radius? Okay, so it's going to be 2 radical 7, or that would be approximately, so we can graph it. We ought to have a good estimate here. It's a little bigger than 25, so the answer is going to be a little bigger than 5. What is it? Did you work it out? Okay. 5.3. Okay, so approximately 5.3. So we're going to go to -3 comma 2, so back 3 and up 2, and then we're going to go about 5.3 in each direction. So there's 3, so about to here. I'm at 2, so I'm going to go a little bit past 7. I'm at -3, so I'm going to go a little bit past -8. Oops, that look a little better, and then I'm going to go down a little more than to -3. Okay, now on this one, I'm going to go ahead and draw a little box on here so I can make this look decent. Got a circle here. There's my center. There's the radius. Any questions? Everybody got that? Okay, go ahead and do the next one, please. Can I slide this over? Let's make sure we're all on the same page. I'm going to collect the x's together, collect the y's together, and move any constants to the other side. So that's going to be an 8. So everything that's there was there to begin with. Half of that is 4. Squared, I get 16. I really did add 16 over here, so I'm going to add 16 there. Half of this is +5, so I'm going to square that. I get 25, so I'm going to add 25 over here. So this is going to be a perfect square of x and that number that I found right there, quantity squared. Y and that number that I found right here, quantity squared. And then I add those together. Let's see. 8 plus 16 is 24. Plus 25 is 49. And why do we like that? Perfect square, because that means the radius is 7, and that means this is centered at 4, -5. So over 4 and down 5, so we're going to be right there. And then we go 7 units in each direction. So that's going to put me at like 11 over here. That's going to put me at -3 over here. Put me at 2 here, and all the way down at -12 here, right? Isn't that what that would be? Whoops, that was a little too far. There we go. And I missed there, so we'll make that nice and fat. There's the graph. There's the information we need to convince people that we know what we're doing, and that's the work that we'd want to show. Okay, are there any questions there? Okay, take a look at the next one. Take a good look at the next one. again, we're trying to make a perfect square with x and a perfect square with y. Okay, like somebody mentioned earlier, is there any extra x stuff floating around here? No, that is a perfect square. We got x squared. Then we've got y squared minus 8y. I'm going to save room for completing the square. The only square that I need to complete is just the y. I've already got a perfect square with x. So half of this is going to be negative 4. That's going to be 16. So this is what I get. I get x squared plus perfect square of that variable and that number that we just found, and center. Don't get tripped up by something easy here. Center is, what's with the x? A 0, and with the y? Okay, opposite of that number right there, and then the radius would be 4. So there's the information we need, and then we're going to go 4 units in every direction here to graph that circle, and there we go. Okay, any questions? Okay, look at the last problem. Any questions? Sure? Okay, let's take a look at problem number 37. Because if you've been paying attention to the things that I've been saying in class, now I realize most of you probably learned something new today about the equations of circles and that sort of thing. But if we put together a lot of the ideas that we've mentioned over and over and over in this class, we ought to be able to figure this out. It says, find the equation of a circle whose center is 0, 0, but passes through 3, 4. Now, if you're told the center is 0, 0, can you come up with most of the equation? Yeah, because you only need 2 pieces of information, right? You need to know the center and you need to know the radius. Well, they just said what the center was. It's kind of like somebody saying, hey, come up with a linear equation. I'll give you the slope. You find the y-intercept. Okay? So, if its center is at 0, 0, then that means it's x squared plus y squared equals r squared, right? That point is on the circle. The circle goes through that point. Let me say that again. That point is on the circle. That point is on the graph. If that point is on the graph, what does that mean? That means it better work in the equation. So if I plug a 3 in for x and a 4 in for y, this is what I get. I get 3 squared plus 4 squared equals r squared. So what's r squared? 9 plus 16 equals 25 equals r squared. So what is r squared? 20. Hold on. R squared is 25. If we said what is the radius would be 5. But here's the equation. X squared plus y squared equals 25. And then we're done, because then we've got the equation of the circle. It's got both pieces of information here. Okay? Here we only had the perfect square with x and the perfect square with y based on what the center was. We didn't know what the radius was until we solved for it over here. But that would be the answer there. Again, what's that based on? Stuff we covered the first week of this class. Say that again, Tyler?
If it's on the graph and it works in the equation.
If it's on the graph, it's got to work in the equation. And if it works in the equation, it's got to be on the graph. Okay? Those things go hand in hand. Any questions? Okay, that is Math 1010. All done with that.